Okay, if we are writing equations using our slope-intercept form, or y is equal to mx plus b, we've learned that the graph of an equation in the form y is equal to mx plus b is a straight line with a slope of m and a y-intercept of b. The form y equals mx plus b can be used to determine the equation of a line when the following information is given. If I can solve for what the slope of the line is, or know what the slope of the line is, and if I can find an exact y-intercept of the line. So, if we're writing the equation of a line passing through the point of 0 and 2, and anytime that x is 0, the y value is going to be the y-intercept with a slope of 5 over 2, I'm just going to say y is equal to 5 over 2x plus 2. For example 2, each line on the grid passes through points with integer coordinates. In each case, state the slope and y-intercept of the line and determine the equation of the line. Well, first one, I'm going to take a look at line 1. So for line 1, I am going to use the y-intercept as one of the points. I'm going to pick one other integer coordinate that it passes through here in order to figure out that this one is going up by 1 and right by 3. So I'm going to say that the slope is going to be 1 over 3, and the y-intercept, or the b value, is going to be negative 4. Which means that line 1 has an equation y is equal to 1 over 2, 1 over 3 x minus 4. For line 2, I'm going to start at the y-intercept. I'm going to find another integer coordinate that it goes through, and to get from one point to the other, I went down by 3 and right by 2, which means that I have a slope of negative 3 over 2, and the y-intercept here occurs at 2. So I have a slope of negative 3 over 2, a y-intercept at 2, and my equation is going to be y is equal to negative 3 over 2 x plus 2. There's my equation. For example 3, determine the equation of the following lines. So, if a line is parallel to y is equal to 1 over 3x plus 4, and with the same y-intercept as y is equal to 6x minus 7. Well, when it's talking about parallel, it means it has the same slope, so all that's really important is I just look at the slope part here and know that it has to be the same. The y-intercept for this one really doesn't matter. So I know that my new equation is going to have a slope of 1 over 3. In the second case, it says the same y-intercept, which means that the slope doesn't matter. I'm just looking at the y-intercept, and the y-intercept is going to be negative 7. If I'm looking for the equation of a line that passes through 0 and 9, so there's my y-intercept, and is perpendicular to a line that joins 2 and negative 6 and negative 5 and 0. So the first is I'm going to find the slope of this original line, and I'm going to say that the slope of this original line is going to be negative 6 minus 0 over 2 minus negative 5. That's going to give me negative 6 over 7. If my line is perpendicular, then I need to take the negative reciprocal of this and say that my slope for the new line is going to be positive 7 over 6, because I need the perpendicular slope. So my equation is going to wind up being y is equal to 7 over 6x, and then we solved for the y-intercept up here, plus 9. For example 4, it says the diagram shows a display from a graphing calculator screen. The intercepts are integers. Determine the equation of the line shown. Well, what I'm really looking for here, the most important thing, is going to be the scale. Because the scale, right here and right here, are going to tell me what all the x values are worth and what all the y values are worth. So for the x values, if it's going up by 5, this would be 5, 10, 15, 20, 25, and 30. If the y's are going up by 7, this would be 7, the next point would be 14, and the point that would be up here would be 21, which it looks like is off the screen because it only goes up to a max of 20. So now I can use this because I can see that I have a b value of 14 and I have a slope. Well, I went down by 14 and right by 20 to get to this point, so I'm going to say that my slope is going to be negative 14 over 20, which I can reduce to negative 7 over 10. So what is the equation of this line? Y is equal to negative 7 over 10 x plus 14. For the horizontal and vertical lines, we've already found with our horizontal lines, any horizontal line has a slope of 0. So state the slope and y-intercept of the horizontal line L1, which is right here. We know a horizontal line is going to have a slope of 0. And in this case, I have a y-intercept of 5. If I'm going to use the form y is equal to mx plus b to determine the equation of this horizontal line, I would say that y is equal to 0x plus 5, but 0 times x, no matter what x is always going to be 0, which means that this is a redundancy that I can get rid of. 0 times x is just 0, so I can just state it as y is equal to 5. No matter what x is, y will always equal 5 every single time. If I'm predicting the equation of horizontal line 2 using line 1, well, this one also has a slope of 0, and here I can see that it has a y-intercept of negative 6. I'm going to say that this is going to be y is equal to negative 6. And when I put it into my graphing calculator, it works. For D, state the slope and y-intercept of the vertical line. Well, the slope, we said for vertical lines, because I can't divide by 0, I'm going to just get that error in my calculator, is going to be undefined. The y-intercept does not exist. So why can't we use the form y is equal to mx plus b to determine the equation of line L3? Because we have an undefined slope which can't be represented by a number, and no y-intercept. So both parts of my slope-intercept form don't actually work. If I'm going to predict what the equation of the line L3 is going to be, well, for these ones, for line 1, we said no matter what x was, because it's got a slope of 0, y would always equal 5. For line 2, no matter what x was, y is always equal to negative 6. Well, in this case, if I'm doing the opposite and I'm doing a vertical line, no matter what y is equal to, in every single case, x is always equal to negative 3. So what's the equation of that vertical line going to be? It's going to be x is equal to negative 3. No matter what y is, x always equals negative 3. Why can't we use a graphing calculator to verify? There is no x equals function. So the equation y is equal to k, where k is a set number, is always a horizontal line that passes through 0 and k. And the equation x is equal to k, where k is a real number, is always going to be a vertical line that crosses through the point of k and 0. If I'm determining the equation of a line that passes through the point of negative 2 and 8 and is parallel to the y-axis, well, parallel to the y-axis means it's also going straight up and down. This one is just going to be x is equal to negative 2. If it's parallel to the x-axis, then it's going to be going horizontally like the x-axis is. That's going to be y is equal to 8.